Pressure is defined to be force divided by area, or you could say maybe force distributed over an area. However, I feel like that definition doesn't really quite tell the whole story of pressure, because pressure is a characteristic of fluids. One could even say that at each point within the volume of a fluid, there is a pressure associated with that point. For some fluids, that might be uniform throughout. It turns out for, like, if you look at water in the ocean, pressure increases with depth, and that's something we're going to be looking at later on. And if you go to some depth and you say, well, how is there a force there? Well, if you place a wall, or maybe if you're in like a submarine and the submarine has these outer, like an outer hull, right, which are sort of like walls or barriers, then there would be forces applied to those walls or barriers that correspond to the amount of pressure that is there. And in that sense, you could say that those are pressure forces. So maybe I could symbolize that by saying F sub P. And if pressure is equal to force per area, then a force due to a pressure would be equal to pressure times area. So another definition for pressure is that if you take a fluid and you put it in a container, and let's say that fluid has a uniform pressure inside this container, maybe it's a gas, then the forces on the walls would be equal to that pressure times the area of each wall. So that's another way of thinking about pressure, which is maybe a little more measurable, a little less abstract. And so in that sense, there are kind of two formulas we can use when it comes to thinking about pressure and solving problems with it. Is we can use the pressure is equal to force divided by area, but we can also use this one, that a force due to a pressure is equal to a pressure times an area of whatever wall, barrier, or whatever it might be is experiencing that force.